Okay, calculate the average kinetic energy of nitrogen molecules at 50 degrees Celsius. Universal gas constant are 8.3 to 10 to the power 7 or per mole per Kelvin. Given that R equal to 8.3 to 10 to the power 7 or per mole per Kelvin. Temperature 50 degrees Celsius, so to 323 Kelvin. Average kinetic energy. What? We know that average kinetic energy 3RT over 2N, and Avogadro's number 6.023 10 to the power 23. So substituting the values and kinetic energy 6.69 10 to the power minus 14 or. At what temperature will the molecule of oxygen have the same root mean square velocity of those of the molecule of nitrogen at 0 degrees Celsius? Given molecular weight of oxygen 32, molecular weight of nitrogen 28, temperature of oxygen what? Temperature of nitrogen 273 Kelvin, root mean square velocity of oxygen equal to root mean square velocity of nitrogen. So we can write root under 3RT O2 over M02 equal to root under 3RT over M02. So we can remove the square root on both sides, and 3RT cancel. So TOT over O2, M02, TNT over Mn2. Substituting the values, we get TO2 312 per Kelvin. Root mean square velocity root under 3RT over M. Average velocity 3RT over 2N. At what temperature will the molecules of oxygen have the same root mean square velocity of those of the molecules of nitrogen at 0 degrees Celsius? Given molecular weight of oxygen 32, molecular weight of nitrogen 28, temperature O2. Okay, we have already discussed about this. Okay, third, calculate the average kinetic energy of molecule of oxygen gas at 27 degrees Celsius. Avogadro's number 6.023 10 to the power 23 per mole or 8.314 joule per Kelvin per mole. We know that average kinetic energy per molecule 3RT over 2N. So substituting the values R and T and value Avogadro's number, we get 6.21 10 to the power minus 21 joule. Calculate the root mean square velocity of O2 molecule at NTP, molar mass M32, at NTP, temperature 273 Kelvin, root mean square velocity what? Gas constant R equal to 8.314 10 to the power 7, or we know that root mean square velocity root under 3RT over M, and substituting the value of R and T, we get 4.61 10 to the power 4. At what temperature the average velocity of hydrogen becomes equal to that of oxygen at 27 degrees Celsius? Average velocity at RT over pi m. So according to question, average velocity of oxygen equal to average velocity of hydrogen. So we can write root under at RT pi m O2 equal to root under pi m S2, and removing square on both sides, we can write TO2 over MO2, TS2 over MS2, RT also at RT also cancel, pi also cancel on both sides. So substituting the values of mass of hydrogen and oxygen and molecular weight of oxygen, we can get mass of hydrogen and temperature of oxygen. So we can get temperature of hydrogen at 18.75 Kelvin. Calculate the root mean square velocity of O2 molecule at NTP, molar mass 32, at NTP to 73 Kelvin, root mean square velocity mu. What gas constant R 8.314 per hour, mu equal to 3 RT over M. Substituting value of RT, we get root mean square velocity. Calculate the root mean square velocity of oxygen molecules at 27 degrees Celsius. Values of R 8.31 for 10^7. Gas constant, molecular weight, temperature, mu equal to root under 3 RT over M. At what temperature the average velocity of hydrogen becomes equal to that of oxygen at 27 degrees Celsius? Average velocity, we know that, root under 8 RT over pi M. What is the most probable velocity of gas? Calculate the most probable velocity of nitrogen gas at 25 degrees Celsius. R equal to 8.314 joule per Kelvin per mole. Most probable velocity, what are a universal gas constant given at 8.314 joule per Kelvin per mole, temperature 25 degrees Celsius, that is 298 Kelvin, molecular weight of nitrogen 28. We know that most probable velocity 2 RT over M. Substituting value of R and T, we get 4.20 10 to the power 4 per cm per second. Calculate the average kinetic energy 28 grams of nitrogen gas at 30 degrees Celsius. Universal gas constant R equal to 8.314 joule per Kelvin per mole. Temperature 30 degrees Celsius, 303 Kelvin. Weight of nitrogen 28 gram. Number of moles of nitrogen, weight of substance over molecular weight of nitrogen, so 28 over 20, so 1 mole. We know that average kinetic energy 3/2 nRT. Calculate the pressure at which 2 moles of ammonia will occupy a volume of 5 liters at 27 degrees Celsius using van der Waals equation. A 4.17 atmosphere per liter square per mole square, and B 0.0371 liter per mole for ammonia. Number of moles 2, volume 5 liter, pressure what? So given value of A 4.17 atmosphere per liter square per mole square, B 0.0371 liter per mole, R 8.314 joule per Kelvin per mole, temperature 27 degrees Celsius, 300 Kelvin. We know van der Waals equation, P plus A n square B square, B minus B and B equal to nRT, and substituting value P equal to 9.332 atm. Calculate the pressure developed in a 5 liter vessel containing 88 gram carbon dioxide at 27 degrees Celsius. Assume carbon dioxide is a van der Waals gas where A equal to 3.590 atmosphere per liter square per mole square, B 0.0428 liter per mole. Given pressure what? Volume 5 liter, temperature 27 degrees Celsius, that is 300 Kelvin. Weight of carbon dioxide 88 gram, molecular weight of carbon dioxide 44 gram, a 3.590 atm liter square per mole square, B 0.0428 liter per mole. are 8.314 per Kelvin or more. Number of moles of nitrogen equal to molecular weight of substance over molecular weight of nitrogen. So 88 over 44 to the number of mole 2. We know that van der Waals equation P plus An square V square V minus An equal to nRT, substituting the values of Np equal to 9.44 atm. The critical temperature and critical pressure for carbon dioxide gas are 31.1 degrees Celsius and 72.8 atm respectively, and the value of R 0.0821 liter atm per mole per Kelvin. Calculate the van der Waals of constants given critical temperature 31.1 degrees Celsius, 304.1 Kelvin, critical pressure 72.8 atm or 0.0821 liter atm per mole per Kelvin. A equal to what? B equal to what? We know that A equal to 27 over 64 R squared Tc square over Pc, and we get A equal to 3.61 atm liter square per mole square. B equal to 1 over 8 RTC over P. 2 grams of oxygen are confined in a 2-liter vessel by pressure 1.2 atmosphere. What is the temperature of the gas is degree in centigrade? Number of moles of nitrogen, weight of substance over molecular weight of nitrogen. So 2 over 32, that is the 6.25 10 to the power minus 2. Volume 2 liter, pressure 1.2 atm, temperature T watt, and PV equal to nRT we know. So T equal to PV over nR. We get temperature in 0 degree Celsius. So 194.7 degrees Celsius. Okay, it's all about some related numerical under gaseous state. B.Sc first year, Institute of Science and Technology, Trivandrum University. Thanks for watching, and request you all like, comment, share, and subscribe. Thank you for patience. That's now. Bye bye. See you again.